Problem 2. You go to a party with 500 guests. What is the probability that exactly one other guest has the same birthday as you? Calculate this exactly and also approximately by using the Poisson PMF. For simplicity, we exclude the birthdays on February 29. Alright, so in this question, there are 500 guests, and one of them is you. And we want to find out the probability that one other guest, and exactly one other guest, shares a birthday with us. And I want to highlight here the fact that they say exactly one other guest, right? And if you've already guessed here, we're gonna be using binomials to model success and the Poisson parameter. Now, what is the binomial? So the binomial, let's say we have 3 dots here, and the formula for the binomial is this. If you are not familiar with this formula, I would suggest you become familiar with it, I guess. Read the book. Now, what does this even say? Let's say we say 4 choose 2. 4 choose 2 will give us the different ways we can group 4 elements into groups of 2. So we can either do it this way, we can either do it this way, we can either do it this way. I'm running out of colors here. Let's see. We can do them this way, right? And for the last 2, we can group them this way and this way. So basically we can group them 1, 2, 3, 4, 5, 6 different ways. And our formula for the binomial is this, which this will cancel out the 4, 3, 2. And this will cancel out the 2 here. It'll be 2 times 3 equals 6, which matches. Now, here we are going to use the binomial, but not as you would have guessed. We're not going to choose out of 500 guests for 2. We go back to the 4 dots example. Let's say this is us, right? We want to exclude these combinations. Because while these 2 are sharing the same birthday, they're not sharing a birthday with us. We only want those that are sharing birthdays with us, which would be 3, right? Which is actually 3 choose 1. And to see that the formula works out, this is what we would get, which would give us actually 3, which checks out. So here we're actually looking for the different possibilities of choosing one person from a group of 500, right? Which would be something like this, times the probability of success to the power of k, which here is 1, times the probability of failure to the power of n minus k, which here would give us 498. This gives us 499 factorial divided by 1 factorial times 499 minus 1 factorial, which will be 499 divided by 498 factorials, which just gives us 499 times the equation up here. Now plugging this in to our calculator gives us 0.34869, etc. Now, to do this question using the Poisson, well, the Poisson approximates the binomial PMF when n is large, right? So in this case, n is 500. That is, let's say, large, right? P is small. P is 1 divided by 365 here, so it is indeed small. And lambda equals np. So here, lambda is equal to np, n is equal to 500, p is equal to 1 divided by 365, lambda is equal to 500 divided by 365, which gives us 1.3698, etc., etc., etc. Now, plugging all of this into the Poisson, we get e to the power of minus lambda lambda to the power of k divided by k factorial, which is e to the power of 1 and minus 1, 3, 4, 9, 8, etc., 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 and 1.398 to the power of 1 divided by 1 factorial. Plugging this in to our calculator gives us 0.34952. And here we can see that these two numbers are indeed similar.